Good day to you, dear grade 9 learner. I hope you're ready for another lesson in mathematics. I am Teacher Jim and I will be teaching you today about modeling real-life situations using quadratic functions. This is based on the most essential learning competencies or MELC's second competency of the 7th week of the first quarter as stated in the K-12 Mathematics Curriculum Guide. So, what shall you learn today? For this lesson, you will be using the module entitled Modeling Real-Life Situations Using Quadratic Functions. This module will guide you to solve real-life problems using quadratic functions. As much as possible, read and work on this module independently. But if you find some parts difficult, there's always people around to help you. They might not know all the answers, but with patience and perseverance, at least they can help you understand better. So, if you are ready, let's go through the module. The What I Need to Know part contains what you are expected to learn from this lesson. Just enjoy and say to yourself the following. I can describe a quadratic function. I can model real-life situations using quadratic functions. And I can solve real-life problems using quadratic functions. Let's go to the What I Know part of the module. This part will check if you have any knowledge about the lesson. Try to answer 15 items. Then see if you got the correct answers according to the answer key on page 17. Take note, faking your score is not the right way to learn. So, be honest. If you got 15 items correctly, this means you know this topic, but you are still highly encouraged to go through the module. If you got less than 15 correct answers, don't worry. You can improve, especially as you learn the lesson through this module. Now, before you go through the rest of this video module, I am assuming that you've already done this part. If you did not, then you should do that first before we continue. Done? Then let's proceed. Let's go to the What's In part of this module. This review will help you remember what functions and quadratic functions are, which are very important in this lesson. A function is a binary relation over two sets that associates every element of the first set exactly one element of the second set. It involves two variables where one is dependent of the other. An example of a function is y equals 2x. In here, it means that the value of y is a function of the value of x. So we can say that y is equal to f of x in function notation, so f of x is equal to 2x. It means that y is the dependent variable and x is the independent variable. The value of y depends upon the value of x. So, x defines the value of y. If x is equal to 5, for example, the value of y can be acquired by substituting 5 for x in the given function y is equal to 2x. So, by doing that, we will be having y is equal to 2 times 5. Take note that the value of x was substituted by 5. So, continuing further, we will be having the product of 2 times 5, which is 10, so y is equal to 10. It is shown that if x is equal to 5, then y is equal to 10. Now, let us do my notation in your module's What's New part. In this activity, you will be given a function statement, then you will write its correct function notation. Are you ready? Okay, let's do this. The first one. The height h of a wall in feet is the function of the number of layers of bricks B formed on the wall. You are correct. That is h of B. How about this one? The salary S for a work done is the function of the number of hours h used for doing the work. Yep, that is S of h. Very good. Now, let us proceed to the what's in it part of the module. In here, we will discuss what it means by modeling real-life situations using quadratic functions. We will also be solving real-life problems using quadratic functions. So, what do we mean by modeling real-life situations using quadratic functions? Modeling real-life situations using quadratic functions means that we apply the concepts of quadratic functions to solve real-life problems. In doing this, we need to apply a lot of algebraic concepts and skills. We can learn more about modeling real-life situations using quadratic functions by doing some examples. So, let us try this problem. The height h in meters from the water of Rolly, a palarong pambansa platform diver, after t seconds upon leaving the diving platform is represented by the function h of t is equal to negative 4.9 t squared plus 8t plus 5. With that problem, we will try to answer the following questions. A. What is the height of the diving platform from the water surface? B. At what time did Rolly reach his maximum height of dive? C. What was Rolly's maximum height of dive? And finally, letter D. How long was Rolly in the air before reaching the water surface? We now need to sketch the graph that represents the trajectory or the path followed by Rolly through his entire dive. We can see that the graph illustrating Rolly's diving trajectory is a parabola that opens downward. The x-axis contains the time t elapsed in seconds during Rolly's dive. The y-axis contains the height in meters of Rolly's dive from the water surface. The vertex is where we locate Rolly's maximum height of dive before he starts going down all the way to the water surface. Now, let us try solving and answering the questions in the problem. Let's do the first one. It says there, what is the height of the diving platform from the water surface? Take note that Rolly was standing on the diving platform before taking off. It means that at the time of 0 or 0 seconds, the height of the platform from the surface of the water can be determined so t is equal to 0. We substitute 0 for t in the function h of t is equal to negative 4.9 t squared plus 8t plus 5. So by doing that, all the t's in the function will become 0. So from the original function, h of t is equal to negative 4.9 t squared plus 8t plus 5, it will become h of 0 is equal to negative 4.9 times 0 squared plus 8 times 0 plus 5. Now you observe that all the t's in the original function became 0. Is that right? Now, let us continue. That will now become equal to negative 4.9 times 0 plus 8 times 0 is 0 plus 5. So, negative 4.9 times 0 is equal to 0 plus 0 plus 5. And then we have 0 plus 5. Therefore, the h of 0 is equal to 5, meaning the height of the platform from the surface of the water is 5 meters. Now, the next one. At what time did Rolly reach his maximum height of dive? Take note that Rolly's maximum height of dive is represented by the vertex of the parabola. Since the time of his dive is located in the x-axis, the time elapsed when Rolly reached his maximum height of dive is the x-coordinate of the vertex of the parabola. We've learned that the vertex of a parabola is represented by the ordered pair hk. It means that the time elapsed when Rolly reaches maximum height of dive is h. We also learned that in quadratic functions, the x-coordinate of the vertex h can be determined using the formula h is equal to negative b over 2a. So, we use this formula to solve for the time elapsed when Rolly reaches maximum height of dive. From the given function, h of t is equal to negative 4.9 t squared plus 8t plus 5, we identify first the values of a, b, and c. We've learned this before, so we know that A is equal to negative 4.9, B is equal to 8, and C is equal to 5. However, we only need the values for A and B. We substitute negative 4.9 for A and 8 for B in the formula H is equal to negative B over 2A. So by doing that, we will be having negative 8 over 2 times the quantity negative 4.9. To continue, we have negative 8 over negative 9.8. And that will now become 0.82. Therefore, the time elapsed when Rolly reached the maximum height of his dive is 0.82 seconds. Next one. Letter C. What was Rolly's maximum height of dive? Since the elapsed time when Rolly reached the maximum height of his dive is 0.82 seconds, we can use this to find the maximum height of his dive. We substitute 0.82 for t in the function h of t is equal to negative 4.9 t squared plus 8t plus 5. To continue, we have h of t is equal to negative 4.9 t squared plus 8t plus 5, and by substituting 0.82 for t, it will become h of 0.82 is equal to negative 4.9 times the quantity 0.82 squared plus 8 times 0.82 plus 5. So again, take note that all the t's in the original function became 0.82. That is by substitution. So, continuing, we have negative 4.9 and 0.82 squared is 0.67 plus 6.56 plus 5. And then we have negative 3.28, which is a product of negative 4.9 times 0.67 plus 6.56 plus 5. Continuing, we have a 3.28 plus 5, and we will now have a result of h of 0.82 is equal to 8.28. The maximum height of Rolly's dive is 8.28 meters. Finally, we have the last one, letter D. How long was Rolly in the air before reaching the water surface? This is asking us for the total time of Rolly's dive until he reached the surface of the water. By the time Rolly hits the surface of the water, the height of his dive from the surface of the water is 0 meters. So, we can assume in the function h of t is equal to negative 4.9 t squared plus 8t plus 5 that h of t is equal to 0. Therefore, we substitute 0 for h of t. So, 0 is now equal to negative 4.9 t squared plus 8t plus 5, or if we write it in the standard form of a quadratic equation, that will become negative 4.9 t squared plus 8t plus 5 equals 0. We now use the quadratic formula x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a to solve for t. Again, we identify the values of a, b, and c. A is equal to negative 4.9, b is equal to 8, and c is equal to 5. We substitute t for x, negative 4.9 for a, 8 for b, and 5 for c in the formula. X is equal to negative b plus minus square root of b squared minus 4ac all over 2a. So let's do that. So that will now become negative 8 plus or minus the square root of 8 squared minus 4 times negative 4.9 times 5 all over 2 times negative 4.9. Now, you have to inspect first if our substitutions are correct. So, if you're done and you found it correctly, let's move on. Negative 8 plus and minus the square root of 8 squared is 64 plus 19.6 times 5 all over negative 9.8. So that will now give us negative 8 plus and minus the sum of the terms inside the radical symbol, which is 162, all over negative 9.8. So the square root of 162 is 12.73. So that would give us negative 8 plus and minus 12.73 all over negative 9.8. Now, take note that there is a combination of two additive operations inside the formula. If we separate the two operations, plus and minus, we will have the following. We can have t is equal to negative 8 if we consider first the plus operation, plus 12.73 all over negative 9.8. So that would give us 4.73 over negative 9.8, and it will give us a value 40, which is negative 0.48. The other one, if we consider the minus operation, that would give us negative 8 minus 12.73 all over negative 9.8. And that will become negative 20.73 over negative 9.8. And it would give us a value 40, which is 2.12. Notice that there are two possible answers, negative 0.48 seconds and 2.12 seconds. However, time can never be a negative quantity in reality. So, we accept 2.12 seconds and we reject negative 0.48 seconds. The total time of Rolly's dive until he reached the surface of the water is 2.12 seconds. There are more activities in your module that will help you better understand modeling real-life situations using quadratic functions. Do the activities on the What's More part of your module by using what you've understood from this video. You have Activity 1 entitled Solve Me and Assessment 1 entitled My Match. If you can watch other videos about modeling real-life situations using quadratic functions if you think you need more information, or you may ask for help from others. To summarize the lesson, do the activity on what have I learned by filling in the blanks to complete the statements. To help you connect this lesson to real-life situations, you have the activity on what can I do. You just need to think of situations in life where you can use quadratic functions. Write as many answers as you can. Now, you can proceed to the post-assessment. Do your best and God will do the rest. And of course, you have the last check on what you have learned in this module and other additional activities that you can do to improve your understanding of the lesson. In using this module, you can constantly check if you have done well in the activities through the answer key on page 17. Now, our motto is honesty is the best policy, not only in your classroom, but also in your home and wherever you are. This answer key is not given for you to have an easy way out of the activities, but it is given for you to know that you are on the right path of learning. That's it for this module. Remember, this is the new normal. You are in control of what you learn and how you learn. Read, practice, and persevere, and you will know. Happy learning, stay safe, and God bless you.